Whereas, there are few issues when you use it for vibration based damage detection, which is what we are following now at this moment in the design, as said by Rice and Spencer. Noise measurements, noise measurements and signal to noise ratio, that is first issue. The second issue could be discrepancy between scaled down model and prototype, because the behavior of these two can be different at certain frequencies. Thirdly, non-linearity in the structural response. The structural response will remain non-linear. The fourth one could be dense distribution of sensors. We are now identifying the factors which are all important in vibration based damage reduction as applied to SHM design in offshore structures. And the last one is influence of environmental factors in real time, which cannot be considered in the lab scale. Is it not? So, there is a problem here. Let us try to apply this concept to a new generation platform which is buoyant leg, abbreviated as BLSRP. Okay. Conceptually, BSLRP look like this. There is a deck which will be connected by the buoyant legs. And these buoyant legs in turn will be position restrained by tethers. Interestingly, this buoyant leg will be connected to the deck by ball joints. And the important feature is that these ball joints do not transfer rotations from the legs to the deck. These are the legs, this is the deck, and vice versa. The water level is somewhere here. This is my mean sea level, but they transfer translations completely. Let us see what are the degrees of freedom such platform has. So, displacement along x, displacement along y, displacement along z. Okay. Similarly, rotation about x, rotation about y and rotation about z. So, this is what we call as surge degree of freedom. We call this as sway, we call this as heave, and we call this as roll, and this one as pitch, and this one as yaw. So, what we mean to say here is rotational degrees of freedom should not be transferred. Yaw, pitch and roll should not be transferred. Surge, sway and heave should be transferred. Okay. So, it is a combination of two different categories of responses. Okay. So, by this logic this platform will remain stiff in vertical plane and remain very flexible in horizontal plane. So, that is the special characteristics of this platform. Okay. These are what we call as BLSRP. They are essentially used for storage and regasification. Okay. They are not meant essentially for production, they are meant for exploration, but essentially and more primarily they are meant for storage and regasification. They are supported on buoyant legs, therefore, it is called buoyant leg storage regasification platform, and this is a very novel concept which came into existence only about 2 years back. Okay. There are a lot of research studies conducted experimentally, numerically and analytically at IIT Madras Ocean Engineering department. I am pioneered in doing this kind of research in this department, and therefore, we are proud that the results of these are essentially novel and newly tried on the research front at IIT Madras, and we want to share this information in SHM design through NPTEL portal for the viewers benefit. BLSRP has many complexities which arise because of the loading condition, which arise because of the geometry, which arise because of the design itself. So, let us try to see how do we use, let us say, wireless sensors to record or measure, I should say very specifically monitor the response of BLSRP. So, to do this we want to make or create a postulated failure. Actually the platform has not failed, but we initiate a failure and then detect the damage and check the safety. Okay, that is the idea. So, now we are examining SHM layout design for a postulated failure of BLSRP. Through this process we will only discuss about the design of SHM at this moment. We will talk about the response and the control algorithms later in the next module. Okay. There are many pioneers for this kind of experiments. Let us say you can refer to papers for more details at Chandrasekhar and Thailammai 2016, Chandrasekhar et al. 2015. For monitoring experiments using wireless sensor networking, one can also refer to very interestingly the studies conducted and recommended by U1O 2008. The recommendation for wireless sensor networking is vibration based monitoring. So, therefore, performance of the platform is going to be examined. Strain, displacement, force, acceleration the displacement is one of the major criteria which controls the design. Displacement is a major factor in design of any systems, why not in offshore structures as well. So, one is interested to identify the level of damage, the location of damage related to displacement and drift. Okay, that is the idea. So, when the platform undergoes dynamic behavior, damage resulting from the members may also have a different duration and bandwidth of acceleration, etc. So, now the primary idea is the acceleration signal measured from a damaged model. How can you say a damaged model? We are creating a postulated failure, we are causing a failure deliberately, okay. Postulated failure measured from a damaged model is compared with undamaged model to know the significance of damage, extent of damage, etc. Okay, that is the idea. Since the study is done on lab scale, extreme wave loading under which the damage can occur endurance wave analysis approach. Peak frequencies of power spectral density functions are considered, which in turn reduces the time history record. Okay, this idea is supported by Dastan et al. 2014. It is also subsequently supported by Lee et al. 2008, Park et al. 2011, etc. So, the design of SHM should be capable of recording or monitoring the relative motion, that is very important, between the waves and the platform. So, friends, in this lecture we have tried to discuss about the design of SHM layout as applicable to offshore structures. Primary to that, we wanted to know the important characteristics to be monitored in offshore structures. We took an example of buoyant leg storage and regasification platform. We explained the geometric features of this platform. We also understood what are the characteristics which are need to be monitored for this platform. We will continue this discussion in the next lecture to see how the SHM layout can be done suiting the requirements to monitor this platform in the next lecture. Thank you very much and bye.